Okay, here's our next pair. We've got our f of x being 2x over x minus 4, and our g of x is going to be x over x plus 5. And we're going to find our sum, and we're going to find our quotient. So again, I'm going to start just by identifying my domain. So if we look over here at our f of x here, the only place we're going to run into a problem is when our denominator equals 4. So our domain here is going to be all real numbers except when x is 4. So since we're just looking at the domain on these pieces, we can think about it as like an exclusive if you want to do it that way, and think about that x can't be 4. And for g of x, it would be that our x can't be -5. When we get to the end, we are for sure going to write our domains as intervals. But when we're looking at especially these kind of rational functions, it is sometimes easier to think about just kind of kicking somebody out of the club for our domain. We just got to kick that piece out. So when we look at doing our sum, our f of x plus g of x, f plus g of x, our f of x, there we go, f plus g of x. We're going to take our f of x, which is our 2x over x minus 4, and we want to add our g of x, which is our x over x plus 5. And while that's not terrible, we can do better. We can get these to have a common denominator. So reviewing that as well, which is not too shabby. Since I have only expressions here, I don't have equations, I'm going to just remove this so I have a little bit more space. I need to multiply by weird looking ones. So if I multiply this one by our x plus 5, because that's the other denominator that we have, and I multiply this fraction by the x minus 4, because that's the other denominator that we do not have a part of yet, that's going to let us get to that common denominator so that we could add our numerators together. So if we do that and we start combining these pieces together, what's going to happen is now I have the common denominator, x plus 5, x minus 4. And in our numerator, we're going to multiply these out a little bit. I'm going to have my x times 2x giving my 2x squared, my 2x times 5 giving us a 10x. Then on my other fraction, we have x times x giving us a positive x squared, and x times minus 4 giving us a minus 4x. So again, that's something we can simplify. We're going to wind up with a 3x squared plus 6x over our x plus 5, x minus 4. I do always encourage us to simplify it as much as we can. See if we can simplify anything out. So I am going to go ahead and factor my numerator just a little bit. I see that we have a 3x as a GCF on these two pieces. That's going to leave us with an x plus 2 as my numerator. And then our denominator, we still have our x plus 5 and our x minus 4. So this is our totally simplified, absolutely beautiful, gorgeous 100% f plus g of x. This is also totally fine. I do want us to get past here. We want to combine those together into one fraction. So we want to combine those together. There's nothing that's going to simplify here. So the only problems we have in our denominator are going to be the same ones we had before. And that's why it's important that we pay attention to the domains, because we should still have those same problem spots. If we had something that simplified out, we still need to keep track of those discontinuities. So for our domain for this one, we need to have everything except when x is 4, because we get a 0 on this piece, and everything except when x is -5, because we get a 0 on this piece. And that's the one thing we can't divide by, is 0. So our domain for this function over here is going to be from -infinity up to -5, and then from -5 up to +4, and then from +4 up to infinity. We've just got to skip over -4 or -5 and +4. So then when we're looking at doing the division, so I'm just going to put a little barrier on the screen here. So looking at our division, when we have our f of x over g of x, f over g of x. There we go. I'm going to set this up as one gigantic monster fraction. So our f of x was that 2x over x minus 4. And our g of x is the x over x plus 5. So I'm going to set that up too. X over x plus 5. And that is nasty and unpleasant. Well, when we have fractions divided by fractions, that's when we're going to use our keep, change, flip. We keep this, we're going to change the sign to multiplication and flip this guy. So we're going to have our 2x over x minus 4 times the reciprocal, our x plus 5 over x. So now I have pieces that we can multiply together. We're still going to keep our denominator in factored form, so we actually don't have to simplify the denominator at all. We are going to multiply out the numerator to make sure nothing simplifies there. So our denominator is going to be x times x minus 4. And our numerator is going to be 2x squared plus 10. 10x. I don't see anything that simplifies out, and honestly, since we're in multiplication right here, this is exactly what it would be in factored form. So I don't have any pieces that are going to cancel out. So when we're thinking through our domain on this piece, we already know that the domains above, we cannot have our x equals negative 5, and we cannot have that our x equals 4. But in fact, we have another piece here. With that division, now we have this 0 in here as well, where my x cannot be 0. So when we do this division, every now and then we'll get a new piece that we can't have in our denominator. Because we had x minus 4 in our denominator before, we had x was minus 5 in our denominator before, and now we also have an x equals 0 in our denominator. So our domain on this one is going to be from negative infinity up to negative 5. And then we're going to go from negative 5 up to 0. And I have to jump again from 0 to 4. And then we're going to go from 4 all the way out to infinity. So we have to jump a lot of different holes, a lot of discontinuities in this one to maintain the fact that we have a function. So we've got to make sure we're keeping our functions intact. We've got to make sure that we are keeping our domains where they need to be. Okay? So let me know if you have any questions.